When you think of a graph, you probably think of the thing behind me, a plot of x versus y values. However, in discrete mathematics, graph theory studies something completely different and much more exciting, in my opinion. A graph in discrete mathematics is a set of vertices and edges. Vertices are points, and edges are connections between those points. So a graph may look something like this. This is a graph where every set of vertices is connected by an edge. Graphs are extremely important because we can use them to model a multitude of situations in real life. For instance, a map is just a graph where the vertices are cities and the edges are roads. Similarly, we could use graphs to map social networks. We could use graphs to map family trees. We could use maps to graph the subway system, where each vertice is a different stop on the subway, and edges are the paths between the subway stops. Now, as I mentioned before, graphs can be used to model social networks, specifically romantic social networks. For instance, if we're thinking of matching heterosexual couples, we can use a bipartite graph. In a bipartite graph, we can have a left set of vertices and a right set of vertices, and the edges will only go between the left and right sets. For instance, we could match this girl to this boy to this girl to this boy, and this boy to this girl, creating a valid bipartite graph. Since graphs are extremely useful, you can use them to model data in a variety of contexts. For instance, in one of my data visualization classes, I decided to use a graph to model the romantic relationships in one of my favorite movies, Clueless. Now, if you haven't seen this movie, I highly recommend because it's a classic. And fair warning, there are spoilers coming up. So in order to model the movie Clueless, I created a bipartite graph where the girls are matched to all of the guys throughout the entire plotline of the movie. Now let's take a closer look at this graph. Here we can see that on the left, we have the four main girl characters, Cher, Dion, Ty, and Miss Geist. Then, through a series of connections and plot points, we can see that each of them is paired to different male characters, like Elton, Murray, Josh, Mr. Hall, Travis, and Christian. While the graph behind me is one-to-one, since each boy is matched to exactly one girl, the Clueless graph is definitely not, since some of the girls are matched to multiple guys and some of the guys are matched to multiple girls. This is because throughout the movie, characters break up, get together, and find new romantic partners, which creates the plot lines that we love. For instance, we can see here that Ty is matched to 3 guys, meaning that this vertex has degree 3. Ty is matched first to Elton, then she's matched to Josh, and finally, she's matched to Travis, her final love interest of the movie. Similarly, Cher is matched to Elton. She's also matched to Josh. And finally, she's matched to Christian, who she doesn't stick with through the end of the movie. Now, usually in real life, we're less interested in how many people someone has been with, and we're more interested in who they end up with. This leads to the natural question: how do we match up a set of girls and a set of guys in such a way that they're in relationships that they're happy in? This is something called the stable matching problem, and we can use it to analyze Clueless. So throughout the film, a lot of different characters get together and then split up. But how do we know who is whose perfect match? How can we get characters together in a way that everyone's happy? Can we put a mathematical model to this? The answer to that is yes. In fact, we can use an algorithm called the stable matching algorithm, which won the Nobel Prize for Economics back in 2012. This algorithm asks, how can we take 2 groups and pair them up such that everyone is content with their partner and nobody wants to switch? So for the stable matching problem, we assume that all the girls have a list of guys who they prefer, and all the guys have a list of girls which they prefer. For instance, Cher prefers Christian over Josh, then Josh over no one, and then no one over Elton, so she'd rather be single than be with Elton. Similarly, Elton prefers Cher, and then he would rather be single, and then he prefers Ty. Dion just wants Murray. Over here we see Murray just wants Dion. We see that Ty prefers Elton over Josh, and Josh over Travis. Travis just wants Ty. Josh wants Cher, and then he prefers Ty after her. Mr. Hall just wants Miss Geist. Miss Geist just wants Mr. Hall. And Christian, we find out, is gay, so he doesn't want any of the girls. So now we can use an algorithm to match all the girls to the guys systematically until they're all paired up with people that they prefer. Here's how the stable matching algorithm works. Every day, the girl will choose her top pick guy, and the guy will choose his favorite girl out of all of the girls that asked him out that day. If the pair is stable, meaning that they wouldn't want to leave each other for anyone else, then that pair is good to go. But if that pair would prefer someone else, then the next day things could change. Alright, let's see how this algorithm plays out in the case of Clueless. On day 1, all of the girls will choose their favorite guy to pair up with. So Dion will pair up with Murray, Miss Geist will pair up with Mr. Hall, Cher will pair up with Christian, and Ty will pair up with Elton. Now let's evaluate. So Dion is with Murray, and Murray prefers Dion over anyone else, which means that that's a stable pair. They wouldn't leave each other for anyone else. So this one's good. Now in the case of Miss Geist and Mr. Hall, it's the same thing. Miss Geist prefers Mr. Hall, and Mr. Hall likewise prefers Miss Geist, which means they won't leave each other for anyone else. And this pair is stable. Now let's look at Cher. Cher is paired up with Christian, but we see that Christian would prefer to be alone than with any of the girls. So he's going to reject Cher, which means Cher crosses him off her list. And now let's look at Ty. Ty is paired up with Elton, but we similarly see that Elton would prefer to be with no one than be with Ty. So Elton's going to reject Ty, and Ty crosses him off her list. It's the end of day 1. We'll erase these pairs. And now let's move on to day 2. So now it's day 2, let's see what the rest of the girls do. Cher, having been rejected by Christian, is going to go to her next choice, Josh. Ty, having been rejected by Elton, is going to go to her next choice, also Josh. So now, Josh must make a decision. He's going to choose his favorite girl out of the girls that asked him out. We see that Josh prefers Cher over Ty, so he is going to reject Ty and be paired up with Cher. We see that Josh is Cher's best pick. Similarly, Cher is also Josh's best pick. So they're not going to leave each other for anyone else. And this match is now stable. Finally, Ty is going to cross Josh off her list, and we move on to day 3, the final day. On the final day, Ty is going to pick her next favorite guy, which is Travis. Ty is going to ask out Travis. So now let's evaluate. We see that Travis wants Ty, and Ty, having been rejected by her first 2 choices, wants Travis more than anyone else. This means they're not going to leave each other for anyone else. And this pair is finally stable. We have now all the girls are happy and in stable matches with the guys. The girls don't want anyone else, and the guys are all content. You can notice that yes, Elton would have preferred Cher over anyone else, but because the girls are the ones asking out the guys in this scenario, Elton doesn't get to pick what girl he wants. He just has to take what's given to him. So now we have above a stable matching of a bipartite graph. So you can see now how influential graph theory can be in modeling our world and solving problems even as complicated as love.